Let's go to question 4. The random variable x is thought to follow a binomial distribution. In order to investigate this belief, a random sample of 100 observations on x was taken with the following results. State suitable hypotheses for testing this belief. Follow a normal distribution. Chi-square GOF test. So, HO, the data follows binomial distribution with 4 and P as the probability of success. H1, the data doesn't follow this binomial distribution. A2, calculate the mean of this data and hence estimate the value of P. We need to figure out the mean first. Then use this formula, mu equals n times P. So P equals mu over n. Therefore, we need to figure out x bar first from this given data. Let's put this into spreadsheet. A for the value of x. F for frequency. Go to menu, go to 4. We are looking for the mean, so go to 1. Then 1 variable statistics, enter. X1 list is A. Frequency list is F. Then enter. X bar equals 1.8. P equals 1.8 over 4. 4 is n equals 0.45. Calculate an appropriate value of chi-square and state your conclusion using 1% significance level. So alpha equals 0.01. First of all, we need to figure out expected frequency. Let's draw the table. Let's put binomial distribution into graph so that we can get this expected value easily. Y equals binomial PDF 4, 0.45, then X times total frequency 100. So times 100. Let's go to calculator. Put a binomial PDF times 100, enter. Then click on menu, go to 7, get this table. Then we got all the expected frequency. Record this expected frequency on our table. Then we need to check whether every single expected frequency is greater than or equal to 5. We could say this less than 5. We need to combine the groups. Since 4.1006 less than 5, combine groups. We need to add these two together. Then we need to combine these two also. 32. Let's work out the degree of freedom. 1, 2, 3, 4. 4 minus 1 for simple case. Then we need to minus 1 again because we estimated the probability of success from the data equals 2. Let's put the data into spreadsheet. F for observed frequency, FE for expected frequency. Go to menu, go to 4. 4 again. Chi-square GOF test, go to 7. Observed list is frequency is F. Expected frequency is FE. Degree of freedom is 2. Then enter. Chi-square equals 18.0. P-value equals 0.000123. Let's draw the conclusion. Since 0.000123 less than 0.01, reject HO. Enough evidence to suggest that the data cannot be modeled by this binomial distribution. An automatic machine is used to fill bottles of water. The amount delivered Y millimeters may be assumed to be normally distributed with mean mu millimeters and standard deviation 8 millimeters. Initially, the machine is adjusted so that the value of mu is 500. In order to check that the value of mu remains equal to 500, a random sample of 10 bottles is selected at regular intervals, and the mean amount of water Y bar in these bottles is calculated. The following hypotheses are set up. The critical region is defined to be Y bar less than 495 or Y bar greater than 505. B1. Find the significance level of this procedure. We will draw the diagram. Under HO, Y bar follows normal distribution. According to central limit theorem, X bar follows normal distribution with mean mu and standard deviation sigma over square root of n, when n greater than or equal to 30. But if the original data is normal distributed, this n can be any number. Amount are assumed to be normally distributed. So we will put Y bar follows normal distribution with 500 as the mean, 8 over square root of 10 as the standard deviation. Then let's sketch the diagram. Based on this H1, this is a two-tailed test, alpha over 2, alpha over 2. This is K1, K2. From negative infinity to positive infinity. Since we are given the critical region is y bar less than 495. So this is 495. K2 equals 505. Therefore, alpha over 2 equals probability of y bar less than 495. Let's go to calculator. Norm CDF. Lower bound is negative infinity. Upper bound is 495. Mu is 500. Standard deviation is 8 divided by square root of 10. Then enter. We got 0.024053 times 2. 0.0481 will be alpha. B2, sometime later, the actual value of mu is 503. Find the probability of a type 2 error. Probability of type 2 error equals probability of y bar greater than 495 less than 505. Given that y bar follows normal distribution with 503, 8 over square root of 10 as the standard deviation. Sigma is 8 divided by square root 10. Then enter. Answer is 0.785.